Yes, a musical intro. Alrighty, that's enough of that. Okay, welcome to Amberskies. There you go. Let's have an amber sky on screen. So, what are we up to today? I'm going to show you how to use this interesting system we developed. I've already started programming actually, so we're going to go through that. Let's see what we have on code. Yes, slight change in the code colors. If they are hard to read, let me know, but it doesn't look like it to me. I can see this better, so I thought, okay, I'll look into this. So I'm on Amber 3D SL up here. Amber 3D, wow, well done. I've actually started it. So what we've got is a GFX loader. We know that shaders was already there. Models, we've got a model now, and a renderer. So let's just back off a second and look at what I've been doing. So does this work? Or do I have to push another button? Let's have a quick look. Oh yeah, it seems to be working. So what I've got at the moment is a GFX loader. And what you do is you so your data goes in to GFX loader. This poops out of a raw model. And all your data gets placed on your GFX card. GFX card, which is that nice little card you have in your computer that does your 3D graphics. So that is like that, and that's all it does. Doesn't really do much more. So that's the idea of a GFX loader. All it does is it takes your data, places it on the graphics card, and returns to you that. Now that raw model plus shader, I don't know why I did a for model plus a shader, if you take those two and you feed them into, say, a renderer, you'll get you could get pitch on screen, and that's slightly screen. Come on, keep working. And that's the idea. Very simple. It's a good starting point for any kind of 3D modeling that you want to do. So that's what I'm going to show you today. How all of this is programmed. And it's actually programmed rather stupidly easy. So first of all we need to do in the program is have that and that. So tick, tick, tick. That data will go into the raw model. So it gives you your raw model. We've already shown that. And the shader we have to get separately. And that's it. We've already done the shader. That's been knocking around in here for ages, so I thought I'd use it. Let's get that going, shall we? Alrighty. Which one is it? Is that one in it? Yeah. So let's get that going. The actual. Let's have a look at the loader. So the loader, it's going to be using a vector, at least one vector, in this case 2. It's going to be using the Qt OpenGL vertex array object, the Qt OpenGL shader program, and the Qt OpenGL buffer. Now this isn't an old version of Qt, and I made a mistake. I thought we needed to use OpenGL for all of this, but we don't. So if we go back to the profile slightly changed. Wow, that's bright. In that we now only have core widgets and GUI. It's GUI that is giving us the OpenGL. So you don't need OpenGL anymore. Obviously I've added all the programs. Nothing else has gone there. I've put common. I've transferred common over here, common.h. I will look at that later on. Oh no, we won't. We'll do it now because it's easy. So common, I transferred over and I added this, which proved to be a problem in Qt. It doesn't Qt doesn't like it. What it does is it does the definitions for the null copy and the assign operators for your constructors in your header files. And I started using it, and it actually started throwing out errors because Qt behind the scenes already has all of this. So where it hasn't thrown an error, you'll see it being used. I don't know why I need the loop delay and all that in here, but it just makes it, for now, easier for me to have it not in my main program. So that's going to probably change quite a bit. Oh yeah, put it on screen again. So yeah, that hash define is what I've added. Null copy and assign. It's a template which gives us the null copy to other, T and other, and the assignment operator. That's the assignment operator there, which is the equals to. So you can put this object is equal to another object. You've got to be careful with it though, because if you then alter the first object, are you altering the one you've taken a copy from? You've got to be very careful about how this works. So hopefully I've done it properly. It doesn't mess up. So let's go back. GFX loader, here we go. Alright, so we've been through that. And we are going to include Amber models role model.h. Because that's what we're going to be sending in. That's our that's our output. So that's our output. Our input is 3D data. Okay. I'm just wondering whether I can put notes up on here. I'll need to look into that because I don't know the notation system in Microsoft at all. How does it work? Does anybody know? Oh, good. I'm going to be famous. Yay! Oh, I've got the wrong keyboard, haven't I? Here we go. I've got a keyboard here. There we go. And yay! I'm famous. Woo! There you go. I don't care about that. I love a bit of chat from the bots. The bots are good, aren't they, eh? You don't half give a load of rubbish out. Not sure how this one really spanks you up, but I might actually look into it and send them a little message back. But hey ho. One of those messages that says, if you are reading this, your hard drive is already dead. That kind of message. I think that's a nice one to send them. So I've got my name spacing going in here properly. So Amber 3D is the program, the big name. everything goes into Amber 3D, and then I use the directory for the second part. The namespace is API because it's the API directory. I know it's in subdirectory of API, but I'm not going that far on the namespacing because it gets silly. 2's enough. Put it that way. 2 is well enough. At the top we have a couple of Q vectors, sorry, of the VAOs, the vertex array objects, and the VBOs, the buffer objects. How does that work? VAOs and VBOs. I'll say in a minute. The shader program is obviously, we need one of those. Nothing happens in the constructor and destructor, and that null copy and assignment actually works in here. But notice I put it private, so only this, the GFX loader, only the GFX loader can allow a copy or an assignment. Nobody outside can do it because that will block them. And that is because there is only going to be one GFX loader. It's going to be used very much at the start of the program and then probably destroyed. We won't need it after that, unless we want to start messing about and start swapping and changing models on the fly, which probably will happen. So yeah, it could be a rather interesting little program, this, because it is only a little program. Oh yeah, and hi to me viewer. Cheers mate, got a cup of coffee here. Well, hey. So we've got our constructor as usual, our destructor as usual. We can set the shader because we need to. You'll see why. The shader, we need to access part of the shader to get things in the right place on the graphics card. The raw model we need. That's our output there. It's an address to the raw model. We load it to VAO positions, that's our input, data, positions, and the number of positions in this case. And what this actually works out is it will create a VAO, it will store data attribute lists, and then unbind the VAO. Data attribute lists are like positions. So those are data attributes. Well, they're not. Anyway, data attributes are part of the shader, but it will store that to the correct part to be used by the shader. I've got to explain this better. So that's the part that we're really looking at. Null pointer on the shader, of course. On the destructor, we are destroying our two VBO and VAOs do need to be destroyed. The shader is destroyed somewhere else, so we don't need to destroy that. So we've got two destructions going on. Doesn't show on one line. We'll hit enter, tab. There we go, we can show it on one line now. Enter, tab. Both the same line really, with two different names. There we go, so it looks better. Just wondering if I want... No, I'm not doing full expansions yet. This is development stuff. It's going to change. Alright, so you can set the shader, obviously. Current shader equals shader. So that's the first thing you do, and then you pipe through your data. So you set your shader, put the data through, and this does the rest. The model itself, we create a VAO, we store our data, and then we release the VAO and we send our raw model out as a new raw model. Blunkety blunk. Interesting things that I've put in like this here. Num positions divided by 3. Why? Because 3 vertexes equals a triangle. So I needed to do that to store it in the raw model. Num positions here is times by the size of a float, because when you're storing it to your list, or your VBOs, which we're just making a list of VBOs. Really, in the end, this will become 0, 1, 2, 3, 4 type of thing. I'll be doing indexing next. Here, it needs it in bytes. So normally I'd send num positions in as bytes, but then this starts looking weird. So I have to be careful how I do num positions. So all I've done is said num positions is 8. Well, in this case, it's going to be 18. It's just the size of the data, how many items of, how many floats you have in your data. In this case, 18, because I've done a square, which is 2 triangles. Down here, we get to the actual create the VAO. Qt makes it very easy. You just make a new one, you create your bind, and you push it back, and we store it in our storage vector, and then we can return the VAO. That storage is for use for us later to destroy it. That's all. So returning the VAO back into our program so it can be used into our main bit up here. This one here. So that VAO gets returned back here. Create VAO. There you go. On the first line. Then we do this store attribute list. What this does, it creates the vertex buffer object. So it creates and binds, and then it allocates the data size. We then need the shader, because we need to enable the attribute array for the attribute. So this is attribute 0, and I'm using simplified. I think I'm using the simplistic one. Here it is, the simplified one. So it only has a location 0, which is position, so it matches. It has to match, otherwise it won't work. So what this is telling our VAO is recording all of this, and it records really everything that we do. So it records that we've made a buffer, and it'll assign it a number and stick it into the VAO list of buffers. It then realizes that we've allocated data and the data size. It records that allocation. It records the create, bind, allocate, and the fact that it's a new buffer. It then records that we're enabling attribute 0 in this case, and that we're setting the attribute buffer 0 to store floats. We're going to start at the beginning. We're going to use 3 floats to make 1 triangle, and there's no offset or anything like that. That's something different, isn't it? I can't remember. Underscore current shader set attribute buffer, open brackets, it'll tell me now. It is the offset, I thought it was, yeah. So offset tuple size stride. Okay. So you can either put a 0 in there or GL, what is it, underscore something or other, it doesn't matter. But that's a 0, that's the attribute buffer that we want to use. They are GL floats. They have no offset. The size 3 instead of 4, which is a quad. You can have triangles or quads. So triangles we're using, so it's 3, and there's no stride. We're not having this buffer use more than 1 type of data. If you're using more than 1 type of data in a single buffer, which is supposedly economical, I can't see why, but it's just messy programming on that stride thing. So I only store 1 kind of data in 1 attribute, and that does that for me. There we go. Oh, wait a minute. Control Z, 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 Control Z, 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 Z. There we go, we're back to what it was. I just don't want to be saving it out again. And that's it, really. That's all you do. To unhook, you then you release your VAO and you send your own model out with your VAO in it. So the raw model actually stores where the VAO and the number of positions divided by 3, the number of triangles, basically. At this point, so let's go and have a better look at that raw model. This will astound you. This is really massive. There you go. See, null copy and assign didn't work here. I took it out. If I put it in, I think I could get an error. Because we are using something that errors it out. But I want to look into this more, so I've left it there. But it has to be in public. It can't be in private, so that's why I think I took it out because it couldn't be in private. That was the reason. Because we are using an equal sign somewhere, so we need the assignment operator. And the copy, because we want to copy it from raw model back out to... Sorry, we want to copy it from there to there. So that copy assignment needs to be public, and it needs to be properly done. I think I've just left it to the compiler to do at the moment. I'm not sure about it. I want to take control of that. It's better if you're in control of it, because I've got a destructor. So really, I've done that. I should take the destructor out. And when you look in raw model itself, all it does is it takes in a VAO and a vertex count, or triangle count in this case. So get 2 getters. So that's what it becomes. It becomes nothing. You see, it's empty. I can destroy it. So I actually don't need those others, the null copy and assign. It's the rule of 3, 4, 5. There's 5 in total. I've forgotten what the other one is. Construct, destruct. Copy, assign. Can't remember what the other one is. There's a 5th one that's done by the compiler as well. Just default stuff that's done in the background. You can take control of it, like you take control of these 2. So this is a very simplistic storage. That's all it does. It just stores. Nothing else. Just stores those 2 items. And that's going to become important later on. So there's my raw models. They're done. I've done the GFX loader. The shaders we already know about. And the renderer. So we've got a shader. We've got a raw model. We can plonk those in to the renderer. The renderer does need OpenGL for one task only. So I've had to put it in, which was a little bit annoying, but so it's only going to take the shader program, the raw model as inputs, and all it's going to do is transfer using OpenGL everything to the screen. The OpenGL command is just to put everything on the screen. So it's again very easy. That's your constructor, destructor, private, renderer. Yeah, that's working nicely on this one. Prepare and render. So let's have a look at those in detail. So your constructor just puts in my GL, OpenGL from. Remember, our OpenGL is elsewhere. It's somewhere else. It's not even in Amber 3D. There is no OpenGL in Amber 3D. I know it sounds stupid, but there's no setup. I haven't even put a window in here to set up the OpenGL. So there's no window in here at the moment. There will be at some time. I'll have to put one in so people can use the OpenGL properly. Which is quite funny, really. So that's all we're doing there. We're just storing the OpenGL address, the entry point for OpenGL there. We ran no destructor really. So that and that null copy and construct and null copy and copy thingy could be deleted. You don't need them. Under prepare, I've just changed the background color from, it was blue. I'm going to be using function key 3. So I've changed it so I knew that it was working. And then we render. So we take the model and shader in. We bind the shader. We get the VAO and bind it. That does all of the operations that we did in GFX Loader. So that sets the shader up. Everything, does absolutely everything in there. We then use OpenGL to draw arrays, triangles from the start, and with that many triangles. So that's why I had to convert it. So that's just the number of triangles to do. Because it knows that the triangles are 3 vertices, so it does the right number of data, basically. That just says start at the beginning. And then we release it, and we release the shader. And that's it. What a renderer that is. Did you think it was going to be difficult? Nope. That's a renderer. It's the very start of a very, very basic renderer, but it does what we want. It takes the model and shader in, and it puts the model on the screen using the shader. Now, if you've done any of my 3D stuff, you know all of this, and it's not new. So if you've done any of the past 3D stuff, it's just not new, but the language makes it easier. Qt makes this very, very easy. I'm just wondering why there isn't a draw. Well, there is, but it's not in the front portion of Qt, it's in the background portion of Qt. So there is a draw there. No, I'm going to keep OpenGL. And that's all the changes. They're all on GitHub. 0, yeah, they're all on GitHub. So you can go and grab these off GitHub if you want the updates. And that's what I did with Amber 3D. It took, because I've been so long away from doing all of this, it actually took a few hours to do it, which was bad really to do so little in such a long time, but hey ho, let's see how we use it. So let's go over to our RPG, which is linked to our 3D, Amber 3D. If you remember me linking it, that was why. Can we shut everything down? Thanks. Right, let's start at the beginning. Nothing changes in here. No, nothing. Absolutely nothing. This is all the same as it was last time I saw you, because that's what we were writing. So that's okay. Resources. I've just made sure that we have the same GLSL shaders in here. That's all I've done there. In sources, OpenGL, here we go. This has had a few changes. Let me get to the header file. Okay. That's okay. I've added this line here, a Q matrix 4x4. If you remember, I was getting that warning. And what I've done, is I've used it just to add M projection, which is not going to be used yet because we haven't got that far. But I've added it to stop the blooming warning. And all I've done is, under resize, is I've put float aspect ratio is a static cast float width divided by height. And you have to do that in C++17 or it will give you an error or a warning if you don't do your static casts. I've checked all of this and that is the correct way of doing it, I believe. you take that matrix, you set it to an identity, and then Qt has a perspective mode. Q matrix 4x4 : perspective. So we can access that, give ourselves a look up and look down, look up 46 degrees, look down 46 degrees out for our view, using the aspect ratio, the screen across by down, width by height. Closest thing can be 10 centimeters. I call these centimeters. So 10 centimeters and 25 meters. I call these meters and centimeters because it's easier for my brain to work in meters and centimeters, or feet and yards or whatever. But it's a lot easier to use meters and centimeters for this rather than think of these two floats as just distances, which is closest and furthest distance, because who knows what that means. You know, it's got no real bearing on reality unless you say, hey, this is 10 centimeters and that is 25 meters. That's as far as you can see, and that's the closest you can see. So that's the end. 10 centimeters to the end of your nose. That's a bit far, but hey ho, I don't care. It works quite nicely. I find that 46 works nicely. It does kind of compress your scene a little. It's up and down. Got to be careful. It's sometimes better to lower that. If things start looking squashed and flat, lower it, because you're squashing them by using too much up and down view directions for center, from center. So that was that bit. Anything else here? Yeah, I can't put my null copy in here because it's in there. It can't be used in inherited classes. You can't use a null copy template because you're inheriting from here. So these have copy and assignment operators. So you can't do it. You don't put it in. Simple as that. Getters, setters, function key. Yeah, that's okay. I don't like that. I don't like that way of doing things because it's hidden in the header file. So that'll be altered. So that's your header file. In here, we have now got our new function key, this. Hey, what? But function key takes an OpenGL. Well, this has OpenGL. Look. It's here. We're initializing this, initializes OpenGL functions. So this, I'll stop it there. And we'll have a look at that. This is why I wanted to fix this. Just have a look at that line. Okay, so let's have a look at this. See, OpenGL functions are there, 3.333 core. It's got a load of other stuff in, but it's also got the context. So if you pass this through, you are passing all of that information through. But it gives you OpenGL. So when it comes to something like the renderer, you saw that I had *GL and then put it m_GL equals *GL. You can then do GL like you can do here. That GL clear color there. If I was to put in this like that, I can then put in GL. You see, it's got all the OpenGL. It's just when you're programming inside of this, you don't need to use the word this. Sometimes I might by accident. So all I've done is I've altered that. We've made a new function key. We've initialized it. that sends up, we'll show you that in a minute. And we've asked it to go. So if we're using function key 3, we said go, 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 go. And that's all we do in our paint GL. There's no update because that does the drawing. So, stop this now. Thank you. I'm glad I got that sorted so I could show you. It was very important that I had to show you. Where's this one? Oh, right. Z. Put it in here. Get rid of it. Thank you. So, that's your OpenGL. Under our function key, this is looking good. Look at this. We are now using a shader program, the core functions. Look, we've got that star GL in again. Because we want to use that part of this. I could put comma something else and drag like the context out of it. But I don't really need to. I can drag it out of here. Because this isn't just OpenGL, it's the whole of the context. It's everything that we created in OpenGL.cpp. It's all stored in there, but I'm only using a little bit of it. So we've got our OpenGL functions, we've stored that. We've got the shader program, we've got the loader, we've got a renderer, and we've got a raw model because we're using all of it. We're going to be using everything in here to make it work. So we have our includes for everything there. That's fine, and all we have is initialize and go. I can't do that again because this gets in the way. I believe. And there was also something else weird about it. I haven't gone into it too far at this point in time. I would like it to work though. All we have then is we set them all up. So the shader is the simplified shader in this case because I'm only using one set of data, which is positions. The loader, make a new one. Renderer, make a new one. Pass it through that OpenGL so that we can do the draw command. And the model, we haven't got one. So that's it. Destructor, there isn't really anything. You'd think we'd have to destroy all of this. Do we? I'm guessing we should. I haven't put it in yet. I think this destructor needs looking at. Only if I can get that null pointer going. But everything gets destroyed anyway. No. So this is a meat and two veggies. This is the whole program. It initializes it once and then it goes multiple times. Wow, isn't that big? Yeah. And I put in a little note for game logic, obviously. We are going to do a square. So there's bottom triangle and there's a top triangle. Those are all your vertices, well, positions for them on screen. The screen is at the center 0, 0. It's -1 to the left, +1 to the right on the x-axis, +1 up on the y, down 1 y, -1 on the y-axis. So that's how I derive these. I only wanted it to fill half the screen. Function. So you make your model like that, and that's it. That's, oh yeah, sorry, no. You put your shader in. You make your model. Really, that line should be there, but I had to make sure that you could see that these vertices were being used for here. Not very clean way of doing it. I don't like it like that. So really, what I should have done is that. So you set your shader. You make your model, and that's it. That's your initialization done. Yeah. How do you load your shaders? Well, it's done here. It actually does it in the constructor. That can be taken out of the constructor a null pointer put there, and you can decide on which shader you want to load, or you can load both shaders. So you could use two shaders, but then we need to store more data with the model to find out which shader to use. And then our function for rendering needs to use the correct shader. So we'd have to have something to replace this, like all the shaders. Or we could load the shaders inside the renderer itself, take this out completely. And then the model tells us to use shader 0, 1, 2, 3, 4, 5, 6, 7, 8, whichever shader, out of an array of shaders. So yeah, expandability is here. Things can be moved around, and they will be moved around. I'm going to keep that modification. Because it's cleaner. And this is a base system. Nothing's in the right place. Like, you wouldn't do that. You'd be loading the model from... You'd load the data from your disk drive, or SSD. SSD, if you've got any sense, it'll be instant. But yay, I'm still famous. Yay, okay. Oh, it comes up on the screen and everything. Oh, wow. So, Harlequin, shout out to you, mate. You're probably being banned by everybody who views this. Well, isn't that sweet? If anybody watches this, they can ban him. Yeah, I think I'm happy with that. Let's run it and see what the results are. Have I not been through anything? 1 second. No, that's all I've added. Nothing happened in here. Alrighty. So let's get rid of you. Clean. Put the terminal up. I've got stop-ins. Have I still? Did I take it off? No, I didn't. Get rid of that breakpoint, thank you. So it looks no different now. Hopefully. I've run out of coffee, Anna. Yeah. I've redone the colour for the background so you can tell that it's not black. So F1 and F2 have remained the same. Okay, just bright colours. But F3 now gives us a square. Something to note about all of this. FPS. About 87. 86 and a third. 85. I moved the mouse, didn't I? 86. Down to 83. 88. Interesting. There's a lot of variation on the FPS. Doesn't really go over 88, what it shouldn't do. Ever. There you go, 76. 86. So that is not affecting our FPS. Our FPS is still being controlled beautifully. I mean, I can increase the FPS for you. Where is it held? Or where are we controlling it? We are controlling it here. Actually, it's not here anymore, it's in common. That was bad of me. Oh dear. It's being controlled here. "10 milliseconds between OpenGL draw calls." That's what's creating the 88 frames per second. If I halve that, it'll double the frame rate, so it should go up to about 160. But what do I need 160 frames for? I'm only aiming at the end of the day for 40. So this will probably be taken all the way down to 1. The 0 just gets taken off, because there'll be so much calculations to do with the physics and everything that this won't be needed anymore. I'm hoping to get it down to 0. That's my hope. But I want to get it, first of all, below 60. I want to be able to press a function key and watch it drop below 60. At the moment, I'm not getting that. So yeah, that's that. What's the next stage of programming? Well, I'm going to continue on with that kind of thing. But I also want to do other things at the same time. Like I want to start thinking about my data. And what we can do with it. Like how we can show on screen in OpenGL. How are we going to show choices and things? I can use pop-outs in Qt. I can use pop-out widgets, which is awkward for me because I want to do this in C++ afterwards. Pop-out windowing isn't something... Oh, wait a minute, yes I can. Yeah, we can use pop-out windowing. I wonder how that works. So the idea is let's have a look. Oh, that doesn't work. Let's move you up a minute. Alright. The idea is on pop-out menus. Oh, this is a bit tight, this lead. Thank you. So let's have a look. Pop-out menus. I'll call it stuff. What happens is a tiny pop-out will come out and it'll have buttons on it, or whatever you want. You can have buttons down the sides or whatever, wherever you want, and it'll have a info in the middle of the screen. That's funny, isn't that? That looks in the style of the main screen. So that's the idea. So what you do is you create a widget. So create a widget and define it. Show when needed. Now that means we need to be able to turn this widget on and off. Easiest way to do that is just to make a Q widget. Can we ask Qt to make it for us? I think we can. No idea how to do half of this. On click, display something else. How do you change your displays? No, I don't want to change display. I want an overlay. Alright. So I want it to come up. I'm tempted. Can we attach this to .ui and then activate it through, say, function key 2? Or function key 1 have their own widgets? Those are interesting. Okay, yeah. It's just, this is just my ideas board. Can F1 and F2 have the, oh god, widgets called attached to the .ui file, because that's important. You see, I'll show you why it's important. Okay, I can do it through here, can't I? There's something happening in the background that most people aren't even aware of. Let's have a look. We're doing this one, aren't we? Build. And where's our actual thingy? Yeah. There it is. Properties. There it is. That's the bit I'm after. Size 2.7 megabytes. 2,818 576 bytes. That's a lot of bytes. Now I normally keep a bit of an eye on these kind of things, but I've been just letting it slide for now. But that's an awful lot. I mean, how much memory do people have these days? What, 16, 816 gig? I mean, it's not in comparison to normal, with today's machines and how much they can process at any one time. This isn't big. But compared to what I program, or what I'm used to programming, this is huge. Even if I try and do it in C++ pure, it's gonna be, I'm only going to shave off 1.5 megabytes. So I'll be at about 1.3 megabytes in just pure C++, without the support of what Qt does for me. And their system, which is brilliant, by the way, is worth every single byte that it gives you. Hold on a minute then. I've just added a load of stuff to this. Properties, please. In comparison, this is only 66,552. Why? Because it doesn't have a display. This has nothing except a little functions and stuff in it. That's still high in my book. I'm used to programming in 16K of memory. Yeah. Those days seem to have gone a little bit, don't they? Whatever happened to that? I might attempt it one day. But not now, because I want to concentrate more on ideas and things to do. So that's part of the things I want to see done. So yeah, I'll give that a tick. So slide you over a minute. All right, on the 3D side, come on, pen. Oh, right, you're in that mode, are you? Come in that mode instead. On Amber 3D, I want to add indexing. So that all of the items can be indexed. If need, we can actually use indexing. I've got a big problem with this. and it's come up in the past where I've looked at, oh yeah, we use indexing to make everything more compressed. All our data can be compressed because we can use an index. So we can use an index that says like use the first triangle, the second triangle, the third triangle. But then again, then I want to use the second triangle again. Then I want to use the first triangle again. Sorry, the first position again. These are in positions, not triangles. My bad. So you could go from position 1 to 2 to 3, back to 2 and back to 1. So you'd have two triangles overlapping there. But no, what you would do is 1, 2, 3, and then you could do a fourth one. Alright. So my square, let's do it properly. My square 1, 2, 3, and 4 is made up of two triangles, as we already know, which is 3, 6. So I go 1. Oh, that's it. Ah, right, I'm accidentally pressing something here. So I go 1, 2, 3 for the first triangle. And then I would go 3, 4, 2 for the second triangle. I have that many, I only have 4 positions. So indexing would take my 6 down to 4. If you can see what I mean. Because at the moment I am drawing two triangles like there. That, oh no, I'm not. That's bad as well. Go over here. Oh, come on. So currently I'm drawing a triangle there, and then I'm drawing a triangle there, which fit together. So imagine them two fit together. So I actually have 6 positions. And that is 4 positions. So it's a way, an old-fashioned way, unfortunately, of saving memory. Because in those days they had to. And I suppose you still do, because they're getting, the models are becoming more complex. Now, my problem with this is that in the past, I haven't been using this when loading models from an OBJ. I've been creating the index myself. So I have been decompiling, or, well, we have been, yeah, literally decompiling or descanning or parsing. We have been parsing from the 4 position. We've been going that way with our parsing. I know it's a problem with the stuff I've done before, which is not good. We really want to create our index from the OBJ file, because the OBJ file actually has it in this situation. That's an OBJ file. Well, we've read it in. We've had it in this situation because we create our own indexing in the parsers. So this time when I read an OBJ file, if you remember, I've been to a lot of trouble with OBJ files and I've done a lot of research on them, and I've actually got as far as, well, not destructing them, but getting as much information out of them as possible. But I don't even know if I've got access to that information, have I? No, I haven't at the moment. That's a good point. Okay, it's back with the mouse. But I need to look at that more carefully this time, because of what an OBJ file looks like. We got an OBJ file to look at. I think if you go back to some of the videos that I've done and look at the way I've done the OBJ files and loaded them in, you'll see that I create, every single time I create the index myself. I read a set of vertices or something in and I index them myself, matching up everything to everything type of thing. But when you think about it, the OBJ file's got all of that information in it, and all I'm doing is I'm decompiling, I'm decompressing it. Yeah, I think that's the best way of putting it. I'm actually decompressing. So we need to find a way of getting around that as well. Okay. I'm not putting that, no. Have I got any keying to do? I'm not sure I have. I think I want to do research now. Alright, let's do some research. I mean, there's no harm in you finding out how I do my research, is there? No, it might be boring. I don't know. There we go. That's what I use to research. So Qt .ui with multiple widgets. Okay, let's have a look at the documentation. Oh, get off. Continue. Is there a way to just add a widget on top? I know there is. But which one of these things does it? And that's an old Qt manual, 4.8, right, okay. Blah, blah, blah. Yeah, you don't have to use UI files, I know. But that's not the point. That's wrong. There are not states or anything like that. There is actually. So this is rubbish. No, this isn't shaking my boat at all. This just tells you how to use it. Signals and slots, basically. Yeah, we know about all of this crap. Let's go end to end. There we go. End to end in different language. Okay. Oh my god, text. Yeah. Concurrent threads. No, thank you. Servers. OpenGL. Add in and Visual Studio. Nothing. Let's make a slot on the button go to slot, then coding for the 3 options for the 3 messages. Okay. I've already got the go to slot for the buttons. On push button clicked. Int return value. Return message box exec. You're actually making the message box here. Setting it all up. Okay. That's fine, but it's not the whole story. Okay. Yeah. Yeah, I know what that is. Okay. Have I got a Qt running? Nope, as usual. Let's have a look in the last session. Thank you. There is something, like a container, say. Ah, stacked widget. Found it. What the hell is that? Alright. I don't think I didn't see it in here. How to use Qt stack widget. If I can remember rightly, we can use it directly in the UI. Yes, for a settings thingy. That'd be good. You can do it through the UI. Oh God, no. Set current index 0, 1, yeah, that just pulls your widgets to the top of a stack. I'm not reading through a UI. Right, so you make a new one. And you're adding it to the, that's daft. Why don't you just access the UI with a stack? So what I would do is I would replace this screen with a stacked widget. Is that possible? It's interesting. I'm going to have to flood over this side. I want to see the whole thing. There we go. So that big black area in the middle is our screen, obviously. Where is it on here? There it is. OpenGL viewport. Okay. Stacked or widget. There it is. Page. Page. So I would take that and that now needs to fill the screen. can't delete it. Okay, it's doing a Microsoft on me. So there goes, widget stacked 2 2. That's interesting. We could have tabbed. I don't want a toolbox. Where does that go? Oh, it went on the same page. Alrighty, this page is one single page. Okay, that's fine. So why isn't this expanding? I don't understand. Alrighty. I'll just do a run on that. Save, Control S. Let's just run that up. Could not find the executable, please specify one. Oh, cancel. My bad. I've got 3D as main. Set as active project. Thank you. Now that'll work. Duh. Nothing's changed here. And I don't see little doobies here. Here. I think we've got it. No shaders attached to the program. It's flashing. Sorry, exit. I'm not bothered about your shaders, mate. I think we've got it then. So stacked widget. Q stacked widget seems to be our way forward. We've now just got to work out how we can add another stack to it. Alright. We've got geometry size policy, minimum blah blah blah. Size policy matters. Expanding. Expanding. Has to match. Otherwise the center part won't work properly. Just make sure that does work. Oh, didn't save it. Sugar. Yeah, that as I thought. Thank you. Saved it. Yeah. Rebuild it, will you, this time? No, we're getting some errors. Oh yeah, I know that's an error. Yeah, that's fine. It's an error on this system, not on the other system. Don't know if code would reassemble it though. No. That's not working. Alright, I'll have to work on that by the looks of it. Yeah, the the whole process, code doesn't agree with Qt on where to put things. That's what it is. That's why it was complaining at me. But yeah, QStacked widget. Alrighty. Preferred expanding. Alrighty. We've got maximum size increment, base size, palette, we don't care. Fonts, no. How do we add to this? No frame. Could have put a frame on it. What does panel do? Ooh, nice. Frame shadow plane. Sunken. Oh, lovely, lovely. Yes, that's possibly a bit more 3D that we're trying to make. I'm just messing, but it doesn't matter. The final program is just going to be that center window, or it's just going to be a stacked widget by the looks of it. You won't have all the buttons on the outside. Put it that way. The UI is inside, not outside. Hello, Muppet. Come to see Daddy. Oh, cute baby. Come on. There we go. Right, where are we up to? We are up to save all. We are up to help. Shift Q, stack. We've got stacked layout and stacked widget. Okay, let's have a look at layout first. Yeah, this is it. So stack of widgets where only one widget is visible at a time. Oh, this is starting to look nice. Add item. Add widget. And returns the index position. Alright. Returns a current. Remove. Set current widget. Right. You get an index and it asks for a Q widget. That's clever, isn't it? So when you put one in, you get an int. What use is that to? You can insert, minimize, yeah, set geometry, yeah, okay. Alright. Can me set current index. Oh, right, yeah, so you can make a 3-dimensional raised panels and stuff, yeah. Alright. Combo box, page 1, page 2, page 3. We've actually got 3 buttons. Yeah, set current index. So you just can connect it. That's nice. I'm liking this. We need to try it out. Yes, we need to try out Qt stacked layout. Right. What's Qt stacked widget then? The Qt stack widget provides a stack of widgets where only one widget is visible at a time. So what is the difference? Inherits QFrame. Hold on a minute. Inherits Qt layout. Layouts, none. So it is Qt stack widget that we're using. But we want to use it from here. We don't want to be using it in our code. I want everything to go into that UI document for the actual widgets that we're going to be stacking. So this just allows you to go to page. This is just for editing then. On page 2, I can put what do we have before? List, table, tree, display widgets. Here we were. Input, buttons. Alright, they give me some extra Qt buttons here. A lot of useless stuff. And quite a bit of K stuff. K is KDE. That's the thing that I've got. I've got phone on here as well. And Sonnet. Interesting. What shall I put here? Right, here we go. Welcome to Amberskies. Okay. Bold, underlined, bold, underlined, size 18. Not there. Chuck it there for now. Page 2 text edit. So I want function key 2 to give me this. Right, save that out then. Let's see if we can do that. This is using Qt widget thingy. Help. That's the stack layout. I want the Qt. I want that one. So it's Qt stacked widget, set current index. Okay. There it is. It's a public slot. Let's take a look and see what it's actually coming up with within the code itself. First of all, so let's go to function key 2. Here we are. Let's try putting a go on it, shall we? Yeah, let's get this one moving. F2, initialized, and blah blah blah. Void go for now. That's what I'm bothered about. There it is, function key 2. Let's just put this down, do some typing. Okay, sorry about this Muppet. Function key 2. Go. And what we want to do here is access the UI. Oh, joy of joys, we can't. Function key 2 has to be disbanded then, because the only way you can access the UI is in here. Okay. 1 second, is this all still working? Well, it won't be with that taken out. Hey -oh. Can these things still actually set the function key and access it normally? No, they can't. Get me back on that UI right now. Go back to that one and Control S. Alrighty, I'll keep you up. Try again. Thank you. That's nothing. Right, so function key 2 should change it. So what have we got? This UI. It's got page 1 and page 2. Stacked widget. Set index. Have we got index? No. Show. Can I send? Emit? No. We can stack them, we can add them. List all members including inherited members. Thank you. According to this, I can set current index. Set current widget. Set current index. Set current. Okay, we'll try that. Yay! Oh. Hold on a minute. It's a computer. It should start from 1. Sorry, 0. So don't make that mistake. Okay, so now if I run this, I should be able to change the screen. Yeah, this is how I do my research. I do apologise if you think it's slow, but there you go. It works. My research methods work. What I do is I follow an idea, I follow a path. And if an idea works, then it works. If it doesn't, we've got a new screen on F2. F3 doesn't make sure that the screen is correct. So what you have to now do, this will cause a problem with all the others. Notice I'm not now using the function key. So if we want functionality on that screen, we should do both. But that comes second. So that puts us back in control. Yay! Because now all we need to do is put because I haven't done this in the right order, that's going to be a 0. Actually, just copy that one again. Set function key after. Oh, just bloody knocked it off. Cutted it. So that's the only one that's different at the moment. So that's all updated. Something failed. What was it? Did anybody see what failed? Oh, yes. Doesn't matter. Oh, the beauty of Qt. We can have as many screens as we want now. How do we add more screens? That's the next problem. It might be a stupid problem, but it is. Property projects, no. Edit. Thank you. I bet that's getting a bit bigger, that UI. How do we add another page? If we go to stacked widget, yeah, we'll get it here. It's enabled, blah blah. Does it have a properties? Size constraints, no. Layout alignment, no. Promote to, no. Go to slot, no. Insert page. Ooh. Next page. So do I have... how do you insert the pages then? Page 2.2. After current page. So make sure you're on 2 of 2 and then after current page. Ah, you beaut. You absolute beaut. We... no. Input display. Text edit. And the text is going to be that. Thank you. A little joke for the English. And it's going to be bold, underlined, and it's going to be size 26. There we go. And there we have it. We can actually use the pages properly now. And all we have to do is make sure page 1 is there when we save. I'll stick on 2. Now I can move you 2. And 1. Yep. This could cause an absolute uproar, because we are now sending out OpenGL to non-OpenGL pages, I guess. Oh, 61. Nice. What can I say? We have a way of dealing with stacked screens. which is what a widget can be if you want it to be. Remember, these are all going to be at full screen. They're going to have no border around it. So what you've got to imagine now for further development is this is full screen and none of these buttons are around it. But if you click on something on screen, well, you don't get that message, but you get something. You can also have floating widgets come up. Try that on the menu. So like a message box. Can it add it through the UI? Doubt it. I doubt it. Performance is okay. Right, so now that we have just extended the possibilities of what we can do here. So this is going to become our 3D scene. We can have a start page. Can leave this on 0 and use page 1 and 2, which is actually page 3, but hey ho. If you go from 0, so 0 we'll assign here, and we'll do 1 and 2 there. That's not as funny though. Does that reset the data? There's a question. I altered something. No, it doesn't reset the data. Good, because there's no save involved. Alright. Yeah. This is looking good. That's actually a text input box I've used. as you just saw. So, on that note, I think we're coming up to the 2-hour mark. We now have the beginnings of designing a program, and we're allowed to use, well, currently, because I haven't added any more, 3 screens. Wow. But we need to now be able to take these buttons away and access these 2 screens from in here. That's going to be interesting. So I'll need 2 of these boxes. Yeah. Look at the button. That's a 3D button, that is. It is, actually. That's what we'll be using. So, in between this research kind of stuff, I'm going to work more and more on the 3D side, because obviously next comes the spinning box and all the rest of it. But I'm not going to do it that way this time. I'm going in a different direction, because this isn't a 3D tutorial. All the 3D tutorials are already on my YouTube site under Amberskies, the Amberskies YouTube site. So you can look them all up there. I mean, they're all basically what I'm doing. Well, they aren't. This is going to be the final version from all of those. All of those were research and me trying to find a different way of doing things, ways in which I could approach OpenGL, and also how Qt reacted to it, how C++ reacted to it. I haven't done a C series. Should really do a C series, but that's a bit more complicated. C. I think that goes beyond what people want to actually learn. I think C++ is the limit, really. But it's heavy duty on the creating those megabytes of programs. Bit not happy about that. And as I haven't had a break today or a cup of coffee and given you some music, I've just worked a solid 2 hours straight through. Well, not worked, but researched my way through. I think I've had enough. So that's where we're up to. We have the first steps into the 3D, and we have the first steps into creating multi-screen, a multifaceted program. Because screen 1 we can now label as something else. It's not going to be a test program. That can now be log on. And what would 2 be? How's about, instead of a data organizer, we write a character generator. Log on. What screen would you like? A welcome screen, character generator. So welcome screen. Character generator. A status. Main menu. Type thing. A main control menu. That would be useful. Take that one off the end. I'll just put etc after that, because I don't know what I want. I haven't brained it through. I haven't thought about it. So I've still got my workboard. So I'm going to be working on indexing. Just put you up. So we've done so far this part. We've just had a look at this quickly. We've just had a quick look at that and how to get extra screens. So I've got that. That's now a tick, which means I'm now on to adding index. That's fine. That was quick. That was a bit of success, which I wasn't expecting. So I'm not on here anymore. Okay. Oh no, we'll do that here. Now we have 3 separate screens. Okay, we can now do a 3-screen design rather than a 1-screen design. Commit. Can I get through this today? Yeah, I think we can. Looks good. Does that work? Please say it works. Yay, that worked. So just check. There's not really much you can see as a difference, is there? Oh yes, there is. What's this? Oh, that's that Stack Overflow rubbish. GitHub development. Yeah, I've now marked the page because I'm sick of going through. Remember when you master development, that little button there, go to development. I'm not using the master at this point. So we're in MMORPG Dev. test. And the CPP should now hold. Yeah, it's worked. It's all come through. So you got your 3012 doobies. Okay, happy with that. Wow, thank you very much. Anybody wants to watch this on YouTube, fine. Don't forget, you can always support Amberskies if you want to. It's up to you. You do what viewers do. Take care and goodbye.